Of a to the mth power times a to the nth power, we copy the base. What happens to the exponents? So this is item 9 on page 3 of the handout. We copy the base and I add m to n. Very good. The next one, a to the mth power over a to the nth power. We copy the base, and what happens to the exponents? I subtract, and always in the same order. From the exponent of the numerator, from the exponent of the numerator, I subtract the exponent of the denominator. Is it okay so far, Becky? Okay, so m minus n. Next one is I raise an exponential notation to a power. And the reason why we reviewed this is because the same rules apply when the exponents are not integers but are fractions, are rational numbers. Okay, so I copy the base. What happens next? Multiply the exponents, m times n. Then we have a product of two factors raised to a power n. What do I need to do? So I was saying then this not to be confused with something like this. I've seen it so often. Students write this. Is this correct? No. We know that because if this is power 3, how many terms do I have to write? Definitely not 2. Power 2 I meant to write. Definitely not 2. We have a contract on this. How many terms? If the power is 2, how many do I have to write? 3 terms. Very good. Good. So please do not confuse the product of two factors raised to a power with the binomial or the sum of two terms raised to a power, which is totally different. I'm not saying you would, but I'm saying that I've seen this so many times. So what do I write? Nth power multiplied by b to the nth power. Excellent. Next one. Of course, we have here that a cannot be 0. Every time we have a denominator, we know that that cannot be 0. It's on the handout. So now a divided by b raised to the nth power. What do we have to write?
A to the nth.
Right. A to the nth divided by b to the nth. Of course, b cannot be 0. Becky, are you okay? Okay. So a to 0, assuming that a is not 0. So if you remember, we said a 0 raised to 0 is not 1. But a raised to 0 is 1, of course, a being not 0. And the last one, a raised to a negative power. Of course, a is not 0. This is just a notation for this fraction. Other questions, Becky? Is this okay? Is this what you meant? Okay. Anything else for me? Other questions for me? Anything else? Okay, I have a 5-minute quiz for you. Open notes on the phone. You'll finish in 2, I think. Thank you. Yep. Thank you. Yep. Thank you. We need more time? Okay. Every time you divide books, I find. Okay. Done. Thank you. Thank you. Thank you. Thank you, Mike. Okay, so let's talk about it. Almost done? Thank you. Okay. Thank you. Okay, so which type of absolute value inequality is this? How many types do we have? Inequalities. Yes, we have a total of 3, but one is an equation and the other 2 are inequalities. Okay, which type is it? Remember, I know I look silly, but it's either this or it's this. It cannot be both. It's either this or this. Which one is it? Right, it's this. Okay, so what are the options then? Right, wonderful. So these are the two options. So it has nothing to do with the middle. It has to be further away from 0 than 6 units. Further away, right? Okay. So now, if you remember, I said I don't know how to solve this, but I know how to convert it into two different inequalities, and now I'm able to solve it. So solving these two is solving this. So procedure for the top one. So what will I do with 1 minus 3x divided by 2 greater than or equal to 6? What is the first step? Multiply both sides by 2. Excellent. So 1 minus 3x greater than or equal to 12. Next. Very good. Negative 3x greater than or equal to 11. Then, yes. So I have this. What happens when I divide both sides of an inequality by a negative number? Right. So this is done. Now I have to go back to the second one. So I have 1 minus 3x divided by 2 less than or equal to negative 6. Steps are the same, meaning multiply both sides by 2. Of course, I subtract 1. And of course, I divide like before by negative 3. And then, yes, I have to flip the sign. And this is done. And I do remember, because it's an OR relationship, I have to use what? The union, exactly. Perfect, excellent. So can anyone give us the solution? X in the interval.
Negative infinity.
Very good.
Negative 11/3.
Very good. With a bracket. Yes, union. Bracket indeed. 13/3 to infinity. Do we all agree with this? Good. Any questions? Okay. I'd like to go back to this handout that I gave you today, and I would like to review what we know and what we don't, and I would like to apologize to you. I have an error here. The absolute value is after 3, not after negative 2. So if you'd like to correct that, it's right here, not here. So page 3 at the top. So it's x plus 3 in absolute value, and then outside minus 2. My apologies. I did not give you one? Are you okay? Good. Okay, so I'd like to, from now till the end of the semester, look at this handout. Yeah, I'm sorry, Becky, you don't have one? Oh, it's right here on page 3. It's a different handout. I don't know if I got a chance to give it. You just came in. Sorry about that. I already could make the correction for you. It's on page 3 at the top. Okay? So the topic of functions is extremely important, and I'm going to come back to this handout for the first few minutes of the class every time we meet from now on. So we can get this embedded in our system. Ready? So definition of a relation, and I said ordered pairs. Just any ordered pairs is a relation, right? Of course, it could be a function, but at least a relation. The definition of a function is a set of ordered pairs that assigns to each x value what? Exactly, or only one y value. Excellent. Domain and range. Can anyone just refresh our memory? What does domain mean? What does range mean?
Domain is possible values of x.
And range?
Of y.
Possible values of y. Exactly. Input and output. So I said the input is the value we replace the independent variable by to get the output value through the given function. Know that the input cannot be just any value. So it depends on the domain. It must be a value that is found in the domain of the functional relation, else the output does not exist. Okay, so now this is extremely important. And again, I will come back to this throughout the entire course, including chapter 12. And you'll see what happens then. For any function, I said, how do I read a function? How do I read it? And here's how I read it. Remember? So it's f of whatever, in this case, equals -3 times whatever cubed minus 4 times whatever squared plus 7. And this is highly connected to evaluating a function. If I don't know how to read a function, I will have difficulties in evaluating it. So, for example, if I want to evaluate this function for 0, what do? I replace whatever by 0. If I want to find f of 2, what do? I replace whatever by 2. What if I want to find f of x plus h, for example? I replace whatever by x plus h. So that's how we evaluate a function. Good. We cannot go through the entire handout because there are functions that we haven't looked at yet. So can anyone tell us what is this function? I know it says in there, but by simply looking at it, what was this function? Yes, it is linear. We don't know this function yet. It's coming up in chapter 11. So this one we don't know yet. But this one we do. So again, I'm hoping that you made that correction. So obviously we've graphed this, not a little bit more sophisticated like this one, but we graph the base function, which is a v function, right? Which is the absolute value. We definitely graphed this function several times already. What function is this? Square root. It's a square root, yes. Last time we graphed it again, including the cube root. Okay, so we also graphed the cube root last time. Okay, we did not get the chance to graph this function yet. It will come up in chapter 7. So chapter 7 will has to wait. We did not look at these two functions yet. It's coming up in chapter 12. They're coming up in chapter 12. So we don't know those yet. This we do. What type of function is this? And we graphed many of them. Piecewise defined function. This is a piecewise defined function. And the way I define this function is it has, as you see, between 2 and 3, it does not exist. Okay? Now, we do not know 14 yet. It's coming up in chapter 12. And here it's still a problem. The examples here are from chapter 12, actually. And the same thing here. So we'll go back to it. Every time we add something, we'll go back to this handout. Okay? So you can put it aside right now. So let's go back to where we left off. And on this handout on page 5. And then we'll go back to our book, back to section 10.1. Because we did not look at any problem from the book, any problems from the book. So we're going to select together. Okay. So radical expressions are fully simplified if 3 conditions are fulfilled. There are no negative exponents in the final answer. That part we know. The exponents under the radicals are numbers smaller than the index of the radical. This we haven't practiced yet. And there are no radicals in the denominators. Okay? But before we get here, I'd like to go back to 10.1, 10.2, 10.3, and select problems from there, and then come back to the handout. Ready? So we are back to 10.1. We learned everything that we need for 10.1. So if you have your book, feel free to choose. If not, I will. From page 593. Okay. Assume that variables represent positive real numbers. Positive real numbers. I would like to be able to simplify the square root of 64y to the 20th. And this is problem 12 on page 593. Okay, I'm looking at this radical and I see that the index is 2. Excellent. And I see that the radicand is formed how? What does the radicand have? Is it a sum? Is it a product? Is it a ratio? It's a product. What do I know about a radical applied to a product? It's okay. Let's go back to our handout. I put it aside. What did we say? What did we say about the product rule? It goes back and forth. I can change the radical of a product into product of radicals, or I can change it back from product of radicals into the radical of a product. So this is item 4 on our handout. So I will use that. So what should I write in that case if I go ahead with that step?
Square root of 64.
Excellent. Times?
Square root of volume.
Very good. I am told everything is positive, so I don't have to worry about anything, right? When I'm told everything is positive, then I do worry about the absolute value, or I don't.
You don't.
I don't. I don't care. Everything is positive. Good. So then what will be the next step here? What do I have to do? I'm trying to simplify. So the square root of 64. That's it. Done. And now I know that there is a very important property that allows me to change a radical into an exponential notation and back. And that was the first one. I did not put it on the handout, though. I put it in our notes. So how will I simplify the square root of y to the 20th? What should I write? Let me write the property right here for you. The nth root of a to the mth power is a raised to m over n. The index is always the denominator. The power is always the numerator. So what will I have? 8 times
y 20 over.
exactly, which is? That's it. This is it. 8y to the 10th power. Are we in agreement with this? Okay, very good. Let's also look at a cube root in this case, like problem 28. So let's look at the cube root of negative 64 x to the 6th power. We are told find each cube root. Suggestions here? Again, I look at the index. The index is 3. I'm told, I don't have to be told anything because it's the cube root. Anything goes. And again, is this a product under the radical? Is it a sum? Difference? It is a product. So what if I split it? How do I split it then?
Cube root of 64.
Negative, because anything goes. That's fine. And x to the 6th, the cube root of x to the 6th. And now I'm asking myself, is there a number that I raise to get,
Negative 64.
right. Is there a number that I raise to the 3rd power to get negative 64? And Riley, I think she is working on the calculator. She will give us. How do we do this with the calculator, by the way? Let's do that. Okay, here it is. I was just finishing up with my pre-calc class. I met with them. I meet with them on Mondays and Wednesdays, and I missed Labor Day, so they gave me the time back today. So they came between 4:15 and 6:15. Okay, so I want to determine the cube root of negative 64. I know that any radical is the same with an exponential notation. What exponential notation would be the cube root? What power would that be? Because that's one way with the calculator. So I'll put in parentheses negative 64. But what do I raise it to? Let's say, again, one option. There are other options with the calculator. Exactly. Thank you. 1/3. Excellent. It is power 1/3. Good. And now I click enter. And what do I get? Negative 4. How do I check? Negative 4 raised to the, we just mentioned that, to the 3rd equals negative 64. There is another way, and here it is. You have a cube root right here under math. So if you want to use that, I'm too lazy to go to math and then scroll down and find blah, blah, blah. I just change the cube root into power 1/3 and I'm done. What will I change the square root into if I don't want to use the square root in the calculator, which is right here with the second key right here, the square root? What power would that be?
1/2.
1/2. What about the 5th root? 1/5. So here's the option. So you have 3, and I think you can choose 4. I never use this one, so I'm old school. I have to put parentheses everywhere. I know the software doesn't require it anymore, but again, old habit. So I come back. I know that this is -4, and then the cube root of x to the 6th. I'm changing it back in my head, if you want, into a rational exponent. And what do I get? That's it. And this is it. So please turn the page to, if you have your book, to 594 and choose the next problem, or I will. Yes, Becky? You have 2 options. One option is right here. The second is right here. So if you want, no, this one. That's okay. And now put 4 and enter, and enter. That's the square root. Is that okay? The cube root? This, okay. So you have you have just math, press math. And you see the cube root is right here. So select 4. And then put -64. I will always put parentheses because I'm old school, but you went ahead without it. That's fine.
So
Yes.
is it not 4x?
Yes. Yes. I don't have to put a raised dot. You're right. Of course. The same thing. Absolutely. Other questions for me? Javier, are you okay? Okay. Good. We had problems like this one, so let's look at one anyway. 54. So this is the square root of x squared minus 8x plus 16. And all I can say is that we have a contract. Signed a long time ago. I look at the index. What is the index? And forgive me, I have to read the problem. Assume that the variables represent any real number. So I do worry now. What do I worry about? That when the index is even, the answer must be, is the index even? Okay, so I have to worry about the answer. If the answer can never be negative, then I will not use the absolute value. But if it can be negative, then I will have to use the absolute value. Okay, so we have a contract. How do I continue? Yes, indeed. How do I factor? Very good. Thank you very much. And the answer is?
Absolute value.
Right. Right? Because x minus 4 could be negative. Perfect. Okay. Let's look at a ratio now. And if you want to select, you can anytime. I'm selecting 72. The square root of y to the 10th over 9x to the 6th. What do we do with this? Again, I'm looking at the index, I'm looking at the radicand, and what do I conclude? What could be the option here? Yes, I will split it. How? The top will be? Very good. And the bottom, and I can split the bottom as the square root of 9 and the square root of x to the 6th as well. Good. So then the simplified form is, in here we are told assume all variables represent positive real numbers, no headache, no worries. Just go ahead. What do I get? Y to the 5th indeed. Yes, indeed.
X
6 divided by 2, x cubed. Very good. Excellent. Okay, let's look at a graph. Are we going to graph a square root or a cube root?
cube.
Okay, let's choose one more time. Cube root or square root? Okay, square root. So let's look at, let's say, yeah, why don't you make one up? We want to make one up. Anyone? I need the square root function.
3x minus 2.
Very good. 3x minus 2. Very good. Okay. What do I start? So the question is graph it. Graph this function. How do I start? Every time I'm asked to graph a function, what is my very first thought? Always. Exactly. Very good. Indeed, the domain. Thank you. Good. Is this a function with problems or is it a friendly function? I don't have to worry about it. Do I have to worry about it or not?
That's problems.
Yes. Problems. It's not a friendly function. What do I have to write, solve to get the domain? And I have to say that with this function, I have difficulties with my pre-calc class. I have difficulties with my calculus class. For some reason, nobody really likes the square root. I don't know why. So, what do I do? How do I find the domain of this function?
3x minus 2c greater than or equal to 0.
Very good. I know now at least one person who doesn't have difficulties with this. Good. How do I solve this inequality? I'm not saying that everyone else does. I'm just saying that one person answered so far. So how do I solve this?
Add 2 to both sides.
Right. I did add 2 to both sides and then? Good. Indeed. So anyone dictate the domain? Very good. So then when I could start creating my chart of ordered pairs, where do I start? Well, 2/3. A little ugly number, but we'll make it happen. Good. So since I don't want to spend time in trying to find something nice, just give me some numbers between 2 or 3 numbers between 2/3 and infinity, hopefully closer to 2/3 than to infinity. And we'll plug them in and we'll get some approximation, whatever it is, and we'll graph the function. So I have to start with 2/3, however. Yes, Becky?
So 3.
You want to put 2 and you want to put 3. Good. Let's also put 6. Okay, so I have to start with 2/3. I have to plug in 2/3. What do I get when I plug in 2/3? What do you think we're going to get?
0.
Of course, of course. So let's plug in 2, plug in 3. I can put this in the graphing calculator. We can do that. So let's go to y equals. Let's do that together. Clear if you have anything in there. So let's go to y equals. We do have the square root. We don't have to use, we have a special button for the square root. We don't have to use power 1/2. So second and square root. Again, you know me, I'm old school. I have to put parentheses everywhere. So 3x minus 2. I want the graphing calculator to allow me to put in the numbers I want. I don't want the calculator to decide based on the settings, right? So make sure that you go to second table set, and make sure that your independent variable is in the ask mode. So scroll down to the right and make the independent, only the independent variable to the ask mode. Do we have this? Do we have this? Yes? Okay. Javi, you have it? Becky, you have it? You want to try? Yes? We continue? You don't want to try? You want me to show you? Say it again. Oh, okay, very good. So you don't want to put the function in so I can show you how to use the table? Okay, so let's go to y equals and put in the square root second and the square root, and put 3x minus 2. And then we go to second and table set. Right here, second and table set. And make sure that you have the independent variable. So we go to second and table set. And then scroll down to the right, press enter. And now we go to second and table. Second and table now. So second and table. And now I can put any numbers I want in the domain. In the domain. So I have 2, I get 2. I have 3. You pick 3. Let me try again. So 2, enter, 3, enter, 6, enter, and whatever else you want. So I have the y values. Just copy them. 2, 2.6, and 4. Okay? Yes? Are you okay? Okay. So let me see your function. You didn't put that. So this is your x. So the second, okay. And now this is 3 times x. This is your x, and minus 2. Right. And now we go to second and table. And now let's put those numbers in. Okay, ready? We're going to look at the graph in a minute, but let's graph it on our own. So, kind of difficult to show 2/3. So I'm taking a unit, I'm dividing it in 3. So this will be 2/3. So that's where the starting point is. At 2 is 2. At 3, 4 is 6. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. The other way around, of course. 6, 4, I'm sorry. It didn't seem right. Here it is. So here's our function. So this is what you picked. F of x equals the square root of 3x minus 2. Can anyone give us the range? By looking at the graph, can anyone establish what is the range of this function?
0 to infinity.
Of course. So the range is indeed 0 to infinity. So now if you want, we can click on graph. So let's click on graph. However, I prefer to select the viewing window. I'm not really interested in looking from -10 to 10. I want to show you how to change the viewing window. I have the graph. Here it is. So there is nothing here, and there is nothing here. So there is no point in having -10, 10, -10, 10, 10, -10, 10. So I will just like to see that, let's say, between -2, -2 here, -2 here, and the graph. You don't have to. You can use the standard viewing window, but I would like to have control over that. So I'm going to say between -2 for the x, minimum x, the leftmost. Yes, Jackie? Oh, of course. Sorry. Thank you. Okay, from -2, let's say, to 10. The scale of 1 is okay. Y minimum between -2 and, let's say, 10. And then press graph. And here it is. There was no point in showing too much to the left of the y-axis and too much to the below the x-axis either. So the graph, as you see, it starts at 0, although it really doesn't show that. So if you want to go back to second and table, and if we plug in 2/3, right, we have to get 0, right? 2 divided by 3, I get 0. However, the graph, be careful. Don't trust the calculator. Trust what you know first. See? Kind of shows that it doesn't start from the x-axis, at least in the software. I don't know what you got. Maybe in the calculator it shows starting from the x-axis, but that was lying to us. Okay, back. I like to look at a word problem here, and then we can move on. Let's see an application of all this. Ready? Let me just check my video, see if I passed the No, I still have time. At the 50-minute mark, I have to. Okay. So, would you like to look at a relationship? I'm on page 5. This is my page 4. I'm on page 595, and I'll give you 2 options. One option is a velocity type of problem. So velocity equals the square root of 2g, this is uppercase G, and this is R. So something like that, and we may be asked to do something with it. And the other option that I'm looking at right now is a formula for the adult body surface area. So HW divided by 3131. So are we more interested in the body surface area? Yes. Okay. So let's go ahead with that. So we are told that there is a formula for calculating adult body surface area, which is B, and this is the formula. So we are looking at this problem, and that is problem 113 on page 595. And it says where B is the individual's body surface area, so B, surface area for the body surface area, in square meters. In square meters, H is the height, the individual's height in inches, and W is the individual's weight in pounds. This is an example in which a square root function is used to relate these 3 variables: the body surface area, the height, and the weight. Okay, so now we can do that for each and every one of us. Let's see. Use this information to answer exercises 113 and 114. Round the answers to 2 decimal places, they say. Find the body surface area of an individual who is 66 inches high or tall, 66 inches, and whose weight is 135 pounds. So we want to determine the body surface area for this particular person. Any suggestions, any recommendations, any ideas from me here? Yes?
Or like
I will write the square root. I will replace the height by 66 times 135. Are they in the measurement units given? Yes. Inches, pounds, correct. And divided by 3131. Again, I recommend, maybe I shouldn't recommend you be old-fashioned, but in this particular case, be very careful how you put it in. I would put parentheses, because otherwise the calculator could do who knows what. So I would put parentheses, multiply 66 by 135. And it's okay now if I write divided by the order of operations, this is okay. 3131, close the parenthesis and press enter. So what is the answer and what does it mean? I see 1 point, it says 2 decimal places, so I'm going to write 1.69, very good. So I'll say B is approximately 1.69. Without a measurement unit, doesn't matter. It's not correct, so meter squared. Very good. So that was just an idea of where radicals are used, and we'll look at that all the time. We are ready to proceed to section 10.2, rational exponents. Everything here is known. There are no secrets whatsoever. We are just going to practice. So on page 601, use radical notation to write each expression. Simplify if possible. So let's say we have problem 15, on 601. Negative 16 raised to power 1/4. And math, this is something you asked me today. This is an extremely important type of situation to look at. Why? Well, can anyone tell us what does this mean? And by the order of operations, what are we going to do here?
Take 16, raise it to the power of 1/4.
And then,
Multiply by negative.
right. As you see, the negative sign in front and the power have nothing in common, in the sense that not to be confused with this, which will not even be a real number by any means, but still, there are no parentheses. So this is really nothing else but negative 1 multiplied by 16 to 1/4. Perfect, thank you. So then I have negative outside, and then how do I change this into what? And what do I write? The fourth root of?
16.
Perfect. Okay, now can I determine the fourth root of 16? Is there a number that I raise to the fourth power to get 16? Is there a number? 2, indeed. Right. So if this is 2, what is the final answer then?
-2.
Negative 2. So please be very careful with this. Okay. Would you like to choose the next problem, or I continue? Okay, I will choose. Thank you for the vote of confidence. That's really nice. You trust me. Okay, so 26 on page 601. I'm looking at x minus 4 raised to 3/4. Let's see what they want. Use radical notation to write each expression. Simplify if possible. So how will I write this? Allow me to stop.